Okay, today we're going to be talking about multiplying and factoring, but with a little bit of algebraic expressions. So the first thing I want you to know is that you can distribute a monomial. So you can use the distributive property and or a rectangle diagram to multiply polynomials. So let's talk about something pretty easy first. So if I gave you just a normal problem, sorry about all these savings, like let's say it was something like 3 times the quantity 4 plus 2, something really easy like that. Okay, now normally when you'd solve this, you would do 3 times 6 and you would get 18. Okay, but you've also noticed that we can do distributive property. We can do 3 times 4 is 12 and 3 times 2 is 6, and that gives us our answer of 18 as well. Okay, a rectangle diagram is kind of using the idea of distributive property in a different way. It's saying to find the area of a rectangle, you multiply length times width. So we could call the length, or the width, whatever you want to call it, 3, and this width, 4 plus 2. Okay, I can separate that up, so this left side's 4 and the right side's 2. And to find the area of each piece, I would do 3 times 4, which is 12, 3 times 2, which is 6. I'd add those together and get 18. So these are 3 representations of the same problem. They will come in handy as we're trying to solve many problems, to multiply them and factor them. So let's go ahead and start out this example. Simplify each product. So here's the quantity, 3x times this whole expression, 2x squared minus 5x plus 1. So you can do it in 2 ways. So you could make a rectangle diagram where we'd have 3x is one length, okay, and then 2x squared minus 5x plus 1 is the other, kind of breaking that up into parts. So to find the area of each piece, so this piece here to the left, I would want to multiply 3x by 2x squared. So there I have 6x cubed. Okay, for the next part, I'd do 3x times a minus 5x. So I'd have a minus 15x squared. And then to do the last one, I'd do 3x times a positive 1, which is just a positive 3x. Because none of these are like terms, I would write my product as 6x cubed minus 15x squared plus 3x. Okay, I like to show you the rectangle diagram because it's going to come in very handy in tomorrow's lesson and some other lessons. But it's not necessarily super awesome for today because I think it would be probably just as easy for most of you to just straight use the distributive property here and say 3x times 2x squared, that's 6x cubed. 3x times a minus 5x is a negative 15x squared. And then 3x times positive 1, that's just plus 3x. So you can notice I'm getting the exact same answer either way. Okay. All right, I want you to try that one on your own. Negative 2g squared times the quantity 3g cubed plus 6g minus 5. Okay, now, so you pause it and then come and check it to see if you got what I got. So I'm going to multiply negative 2g squared times 3g cubed. It's going to give me negative 6g to the 5th. Okay, then I'm going to multiply negative 2g squared by 6g. I'm going to get negative 12g cubed. And then I'm going to multiply negative 2g squared by a minus 5. So remember, this is going to be a negative times a negative, so it's going to make a plus 10g squared. Okay, none of these are like terms, so that's as far as I can go, and I'm done. Did you get the same answer? Okay, so after you're good at multiplying, what we're going to do is work backwards, factoring a monomial from a polynomial. So usually when you factor, like if I told you to factor 15, you would say, oh, well, that's 3 times 5. You pull out its factors, the things that multiply to equal it. We're going to do the same kind of thing here, but it's a little more complex. When you factor a monomial from a polynomial, you find the GCF of all its terms. Okay, so that means the greatest common factor. So what I want you to do, all I want you to do first is find the greatest common factor, so the biggest number that's going into each polynomial. So if I gave you just, let me see if you've got this with numbers. If I said, hey, find the GCF of 12 and 20, you're telling me the greatest common factor that goes into 12 and 20. So you're looking for the biggest number that goes into both. So in this case, the GCF of 12 and 20 would be 4. It's the largest number that goes into both. If I ask you to find the GCF of, say, like x squared and x to the third, x squared is the biggest factor of both of those because like x squared times 1 is x squared and x squared times x is x cubed, so x squared goes into both. Okay, so thinking about that with GCF with numbers and with expressions. So here I've got this polynomial, 8x squared minus 16x plus 12. So when I'm looking for a GCF, I'm going to look for a number or an expression that goes into all three of these terms. So for the number 8, 16, and 12, 8 goes into 8 and 16, but it doesn't go into 12, so you're going to have to try something smaller. 4 goes into all three of those. So 4 is my number part, and then I'm going to look at my expressions too. So x squared, x, and there's nothing there, so it's not going to have any variables with it. So the GCF of that expression equals 4. Okay, let's look at another one and see if you can do a couple, actually both of these, see if you can do them on your own. So all I want you to do is see if you can figure out what the GCF is, the greatest common factor that goes into all of them. Okay, so I like to look at number part and then variable part. It just helps me to organize myself. So here I'm going to look at 15, negative 60, and 10. Well, the biggest thing that goes into all of those for a number is 5. And when I look at my variables, x to the 4th, x cubed, x squared, the biggest that goes into that is x squared, goes into all of those. It goes into x squared one time, it goes into x cubed x times, and it goes into x to the 4th, x squared times. So my GCF is 5x squared. Okay. When I'm going to look for my GCF of negative 12x squared y plus 18x cubed y squared minus 24x to the 5th y to the 5th z squared, or just z, I'm going to look again, I'm going to break it up into each part to help me organize. So negative 12, 18, and negative 24, it looks like the biggest number that goes into all of those is 6. When I look at x squared, x cubed, and x to the 5th, looks like the biggest one that goes into everything there is x squared. And then I'm going to start looking at my y's. When I just look at y squared, and y to the 5th, what looks like my biggest one that still goes into everything is a y. And since the first two terms don't have a z, there's no z's that goes into all of it. So 6x squared y is my GCF. Okay, if you find yourself getting pretty good at GCF, we're going to actually use the GCF to factor some expressions now. So when we use the GCF to factor each polynomial, the first thing I need to do is figure out what that GCF is. So if I've got 4x cubed minus 8x squared plus 12x, I'm going to look at the numbers first, 4, 8, and 12. It looks like 4 goes into each of those. When I look at my variables, x cubed, x squared, and x, it looks like x goes into each of those. So 4x is my GCF. A good way to factor this might be to look at a rectangle diagram. Okay, so what you have, 4x will be either the length or the width. Okay, and in the middle you have 4x cubed minus 8x squared plus 12x. And basically what we're looking for are what are the two dimensions. So what do you multiply this 4x by to get each of these terms in the middle? So if I said, hey, what do I multiply 4x by to get 4x cubed? Well, the number is just a 1. X times x squared gives me x cubed. So that will be x squared there. To get from 4x to negative 8x squared, I have to multiply by a negative 2x. Okay, because negative 2 times 4 is negative 8. X times x is x squared. And to get from 4x to 12x, I just have to multiply by a positive 3. That's it. Okay, when you write it in factored form, we write it as the product of the two expressions that multiply together to give me 4x cubed minus 8x squared plus 12x. So what I'm doing is I'm writing 4x times the quantity x squared minus 2x plus 3. Okay, that should be my final answer. To double check that you're right, you could try to multiply this out and make sure it really equals your original. So 4x times x squared is 4x cubed. 4x times the negative 2x is negative 8x squared. And 4x times 3 is positive 12x. And that's what my original expression was, so I've checked it and I'm done. Okay? I would really like you to try these last two on your own and then see if you can get it right. All right, so first step, make sure you've paused. Okay, and then come back and just check. So you've got to find the GCF first. So I need something that goes into 18, 45, and 36. The biggest factor that goes into those is 9. A to the 5th, a to the 3rd, a squared. The biggest one that goes in is a squared. So I do like to organize that with the rectangle. It helps me out. I know 9a squared is going to go here. I've got 18a to the 5th minus 45a cubed plus 36a squared. Okay, and I'm going to look at each part separately just to help out. So 9a squared, it has to multiply by 2a to the 3rd to get that first term. It has to multiply by negative 5a to get the second one, and just by positive 4 to get the third. So when I factor it, I say it's 9a squared times the quantity 2a cubed minus 5a plus 4. Okay, and then the last one, we'll see if you got this one. So I'm looking at 42, 28, and 56, and that looks kind of challenging, but 14 goes into all of those. If I look at x to the 5th, x cubed and x squared goes into all of those. And then if I check out y to the 3rd, y to the 4th, and y to the 4th, y to the 3rd goes into all of those. Okay, so I'm checking out my GCF on the side is going to be 14x squared y cubed. And then if I'm in the middle at 42x to the 5th y cubed, okay, I might have to add a little extra here, negative 28x cubed y to the 4th. All right, I'm adding to my rectangle, 56x squared y to the 4th, and I'm going to figure out what I needed to pull out. Okay, so to get from 14 to 42, that's times 3. X squared to x to the 5th, that's times x cubed. Y to the 3rd times y to the 3rd, that's just times 1. I don't need to put it in. To get from 14 to negative 28, that's times negative 2. X squared to x cubed, that's times x. Y to the 3rd to y to the 4th, that's times y. Okay, and same thing here, 14 to 56, that's times 4. X squared to x squared, just times 1, don't need to put it. Y cubed to y to the 4th, that's times y. So my factored form, I'm going to write 14x squared y cubed times 3x cubed minus 2xy plus 4y. And I'm done. All right, we'll practice this for a few days. Hopefully you got a good understanding, at least an intro of what's going on here, because you'll use it a lot.